In Chapter 10, we're asked to investigate the strength of evidence. And in that, what we're really looking at is whether or not it's possible to have results from an experiment assuming some information about a population. So, in order to investigate what this means, we're going to look at a game that you might play with your friend on flipping a coin. So, we know that if we flip a coin, there's two outcomes. So, let's take heads, meaning you win, tails, your friend wins. And you play this game 5 times, and in all 5 games, tails comes up. So I wonder if he's cheating here. So I wonder what's the probability then of getting 5 tails from a coin that's flipped? We've seen this probability question before. We know that if we wanted to find the probability of 5 tails in a row, that would be the probability of a tail and a tail and a tail and so forth. And anytime I take an and probability like that, I'm going to multiply those probabilities together. So the probability of getting a tail on a coin is 1/2. So we would have 1/2 times 1/2 and keep going, or in other words, 1/2 to the 5th power, resulting in the product being 0.03. To interpret this probability, if we flipped a fair coin 5 times in 100 different trials of that experiment, we expect only 3 of those 100 experiments to result in all tails. So, in other words, this observation we see is possible, but it's not exactly likely, which we've discussed previously. So, you might make 2 conclusions from this outcome. The first conclusion would be that your friend is not cheating and just happens to be lucky that day. Or what if your friend is not using a fair coin and is therefore cheating? Fair coin meaning that it is more likely to result in a tail for the friend as opposed to the head for you. So you've got these 2 possible conclusions, and you're asking yourself, is your friend cheating? Or did you just happen to get an unusual result from a fair coin? So those are the 2 choices you have. That is the idea behind hypothesis testing, which is what we look at here in this chapter. We're going to make an assumption about reality, right? Where we are assuming in a fair coin, the probability of getting a tail is a 1 in 2 chance. That's the assumption. And then we're going to gather some data. In other words, we're going to create an experiment or look at a sample and then determine whether or not our sample is going to contradict that assumption we have on our population, the assumption that it is really a 1 in 2 chance or a 50% chance of getting tails. So, hypothesis testing. The main objective in this chapter then is going to be for us to look at how unusual it would be for us to get our statistic, in other words, our p hat or an X bar, right? Those are both sample statistics. How usual or unusual would it be for us to get those statistics under many, many repetitions? That's our definition of probability. And we can conclude that if our observed value, if our p hat or X bar is unlikely to have happened, then there's going to be what we say as strong evidence against that claim from the population. There's going to be strong evidence that our assumption about the population is not going to be true. Or if our observed value, that p hat X bar, our sample value is not really unusual, then we have evidence that our assumption or population claim is therefore plausible. And those are the 2 concepts, whether it is likely or unlikely to happen. And our conclusions would be whether or not we have evidence against our assumption for the population or whether or not our population's claim is plausible.